On to division. What does it mean to divide something by a number in visual algebra? Well, we've learned what it means to multiply something by 3, say. And the meaning was that whatever is in here, make 3 identical copies. Division is the reverse. It means to put something in here and to divide it up into 3 identical parts as best we can, and then retaining just a single one of them. So for example, let's look at 12 divided by 3. So let's maybe make a little bit more room here. And now we try to fit 12 dots in here and try to partition them equally among these 3 slots. So that is quite easy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we read out the content of a single one of these slots. So that would be 4 dots. So 12 divided by 3 is 4. Quite easy. Now, what happens if we have a very irregular arrangement of dots? So we are given the dots maybe like this, and we also want to divide them by 3, and it's not really obvious what kind of rectangular array they should be. We don't have an empty array and count the dots as we draw them, they are already drawn. Well, we try to find groups of 3 in here. So maybe here's a group of 3, and here's another one, and here's a third one, and here's a fourth one, and a fifth one. But we don't want to divide into groups of 3 dots each. We want to divide the whole thing into 3 groups of dots each. So we actually retain 1 dot from each of these groups. So maybe this is our first grouping, and then we take, say, this one and this one and this one, and so this would be a second group, and then we are left with 1 dot from each group left over, and this one. So the actual division by 3 consists in these 3 groupings, which each contain 5 dots. So 15 divided by 3 gives 5. The red one would be a division by 5, giving 3. Okay, so in general, division is the reverse of multiplication. So when we look at our general shape for multiplication table, like this, and we say, for example, this here is a variable b, so in this direction we multiply by b, then we consider this to be a variable on its own, the result of a multiplication by b. So if you go the other way around, so in this way this would be division by b, we get a divided by b. And quite naturally we also get b divided by b gives a 1. Everything is quite natural here. And just as for multiplication, we have a few algebraic laws for division, and the first ones I want to illustrate in a generic multiplication table like this. And you might remember that we started this by putting a here and b here, and this is 1, and then this is the product a times b. And we have seen, for example, that we could obtain ab by first multiplying a and then by b, or first taking b and multiplying by a. That was the commutative law of multiplication, and the whole total result is a multiplication by ab. So let's draw all of that in. And now if you want to look at the properties of division, we don't put these things in here. We put other things in here. So for example, what if you put 1 in here? Well, we get, for example, here this would give us A, and then A undo the multiplication by B, that would give us A divided by B. So the net result of going from here to here is multiplying by A divided by B. Now, what happens if we don't put 1 in here, but some other variable C? This becomes C times A, and then we undo the division, and then we undo the multiplication by B, which is C times A, everything divided by B. But we've also learned that this is C times the quotient A divided by B. So we have the law that C times A divided by B is the same as C times A divided by B. But we've also seen that we can go a third way. We can first divide by B and then multiply by A. So this is also the same as C divided by B multiplied by A. So this is a direct consequence of associativity and commutativity of multiplication. What else can we find out in this diagram? Let's say we put our variable C in here. What do we get then? Well, we get, and if you want to go here, we know for 1, by the direct route, this is just undoing this multiplication by AB. So here we get C divided by a product AB. But we can also look at this as first dividing out A and then dividing out B. So this is the same as C divided by A divided by B. There's yet another property of division. And there's a third property of division that we can find if we put our variable C in the third possible slot, that is here. Because going from here to here, we've seen that this is the reverse of this multiplication by A divided by B. So here we have C divided by A divided by B. That is a nested division, dividing by something that is a division. And we can also make sense of this by going, for example, this way. That is first dividing out A and then multiplying by B. So this is the same as C divided by A multiplied by B. And there you have the algebraic law that actually applies to double fractions. It is completely analogous to the double sign rule for subtractions. Here just with multiplication and division. Beautiful.